Hey guys, welcome to today's lesson. We're looking at the quadratic function, or the quadratic polynomial as it can be called. So basically the aim of today will be looking at drawing a parabola. Okay, drawing a parabola, but making sure that when we draw in the parabola, we can draw in important properties such as the x-intercepts, drawing in, of course, the y-intercepts, drawing in our axis of symmetry, and looking also at putting in our turning point. So basically 4 pieces of information there that we need to be drawing onto our parabola in order to draw it effectively. First of all, I'm just going to look at the x-intercepts. Remembering back to our sketching in our functions, that if I want to find the x-intercepts of any graph, not just a quadratic function, we always let y equal 0. Okay, in that case, what we'll be doing when we have a quadratic function, we'll be solving a quadratic equation. And that will lead to, I'll write that there, solve a quadratic equation. Now that can be by either factorizing first, or you might also look at using the quadratic formula. Remembering the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so that's certainly something you need to be thinking about. The next thing we're looking at is obviously the y-intercepts. Remembering back when we want to find the y-intercept, we let x equals 0, and that's often the easy one. The axis of symmetry, hopefully you remember back to probably year 10, maybe even year 9, that in order to find the axis of symmetry, you can either do it by graphical means. That means by, if I've got a parabola like this, okay, looking halfway in between the two x-intercepts and figuring out what my axis of symmetry is going to be. But remember using this formula, x is equal to negative b over 2a. That's, of course, when we have the format ax squared plus bx plus c, okay, where obviously the a is in front of the x squared, the b is in front of the x, and the c is that number at the end of it. And then the very last part is looking at our turning point, where once we know what our x value is, we sub the x value of the axis of symmetry into equation to find the y value. Remembering that if it is a minimum turning point, it's going to be a happy face parabola. If it's a maximum turning point, then it's going to be a negative graph. Okay, and obviously, if I know that's going to be my axis of symmetry, then I put that x value into that equation, it pops out with that y value there. Okay, so these are all the bits of information that we need to know inside out. So particularly we need to know how to find the x-intercept, the y-intercept, the axis of symmetry, and the turning point. Okay, so let's look at a particular question to start us off with. We'll look at y is equal to x squared minus 4x. Okay, so this is a slightly different parabola. It's not going to be just a y equals x squared plus 4 or minus 4. This time it's minus 4x. So it's going to shift to one particular side. Now you can either draw your parabola as you're going through, okay, or you can do it at the end once you know what all your important points of information is going to be. So my 4 points of information or thereabouts. So the first one, we're going to let y equal 0. Therefore, we're going to have x squared minus 4x is equal to 0. Now, remembering we can do this by either, that's all, it's now a quadratic equation. We can either do this by factorizing or using the quadratic formula. For this particular example, I reckon factorizing is probably going to work. I'll look at my 2 terms, because I've only got 2 terms there. It's not a difference of 2 squares, but I'm going to take a common factor out to start with. Always take a common factor out if you can. So I get x outside of x minus 4 is equal to 0. That then makes x equaling to 0 or x is equal to 4. So what we've now got are my two x-intercepts. The x-intercept of 0 and 4. So obviously 0 is going to be that point there. And 1, 2, 3, 4 is that point there. So that's my two x-intercepts. My second point is I need to find what my y-intercept is going to be. Well, hopefully you can already recognize that that's already cut at the y-axis, so automatically that's going to be my y-intercept. But also we can let x equal 0, sub it back in, and obviously we're going to get 0 there, because 0 squared minus 4 times 0 is 0. So that's my x-intercept, so my x-intercept and my y-intercept in the same point. Now, my next stage is looking for that axis of symmetry. Now we can either do that by looking at that this is 1, 2, 3, 4. Okay, so that's my one x coordinate, x-intercept, sorry. So we bounce one in either side. So we can probably recognize straight away that between 0 and 4 is going to be 2. So that's going to be my axis of symmetry there, and that line x equals 2. We could also do it by putting in the x equals negative b over 2a. In this case, x is equal to, well, b is negative 4. So minus minus 4, that's positive 4 over 2 times 1 is 2. 4 divided by 2 is equals to 2, and that works out nicely. Now my last point of information, I could start drawing my parabola here, but the problem is I don't know how far that parabola will go down. It might be like a really short parabola, or it might be a really long parabola. So my last piece of information that we need to find, as per that last page, was my turning point. Now we know that my turning point lies on the line x equals 2. We're simply going to sub in x equals 2 into my equation. So y is equal to 2 squared minus 4 times 2. Well, 2 squared is 4. 4 times 2 is 8. So 4 take away 8 is negative 4. So 1, 2, 3, 4. So that there's the point 2 comma negative 4. And I'm going to have my nice parabola. A bit harder to draw that there. It'll also look quite nice. And I've drawn my parabola. So let's have a look at my 4 pieces of information. I've got my x-intercepts, my y-intercepts, my axis of symmetry, and I've got my turning point. And it happens to be a minimum turning point. And voila, we are completed. Okay, so again, just reflect there. When drawing a parabola, first of all, we want to find our x-intercept. We want to find our y-intercept. We want to find our axis of symmetry, and then we want to find our turning point. Now just remember, when you're finding your x-intercepts, that is by solving the equation, which can be done by either factorizing or using the quadratic formula. Either way, you're solving it to find out what x is going to be equaling to. Okay? If you can't remember how to factorize or how to use the quadratic formula, please go back and look at previous lessons, particularly on equations and quadratic equations. That will give you a much better idea about how to find those two x values. Okay, guys? It was a fairly brief tutorial, but hopefully you've got the hang of it. For those of you in my 2-unit class, this is directly related to exercise 9.1 on around about page 349 if you're using the 2-unit textbook. Okay, guys, hope this made a bit of sense and it was helpful. Let me know a bit of feedback if you needed some more information. Have a great day.